In this video, I want to show an alternate way to read a file. In this case, we're going to read the file in just one line at a time instead of reading in the entire thing with read. The way that we read one line at a time is we use read line instead of read. In this example, I'm going to reuse some of the code from the video that we had done earlier. And in this case, we just have the same file, which we had the text file that had 1,000 bases, and we're just going to use that again. So I've opened it up here for input, and we're going to do some manipulation, and we'll write a copy back out to the disk file. But this time we'll do it one line at a time. And in fact, the output file that we produce is only going to have 2 lines in it. So let's just suppose then our goal here was to just extract part of this original file and then make a much shorter file that we'll write back out to the C drive. Now, to begin, read in the first line with read line. So this illustrates the new technique that we're going to use. Now, we still need to have a variable, so I'm going to call that DNA_line, which represents one line of data from the file. And in order to read that in, we just use our pointer, our input file pointer, and we use read line. Okay, so that's different. Read line instead of just read. So this reads one line at a time. Read one line from the file. Now, the way that we determine one line is that embedded within the file there must be some \ends indicating that we have end of lines. And let's go take a look at the file and I'll show you that they're there. So here's the DNA file that I'm reading from, and you can see the name of it, sample DNA 1000.txt. So it has several lines. So here's one line, and I think there are 60 bases there, but then there's an end of line over here. So when we do a read line, it stops after it reads that first line. Only the first line of data will be copied into the program, stored in our DNA line variable. Then if we want to read the file again, we'll get the second line, and it will stop when it reaches the next end of line that shows up here. So we can go through this file and we can read it just one line at a time by using read line. This will do it. We need the DNA line is the variable that saves the information. We'll read that line in, and we'll save it here in the DNA line. Now, let's do some manipulations with this, and let's first of all, let's print it back to the screen so we can really see what we read in. So let's just do print DNA line, close parentheses, and let's print out how many characters it has. So we did this last in one of the previous videos too. So print, and let's print out the length of the file, or the length of the line. Okay, the length of the line is, and we'll close that with a double quote, and then we'll get the length and convert that to a string. So we'll concatenate, convert to a string. len is the length function, and DNA line is the variable. Okay, so again, make sure you have all of the closing right parentheses over here. So this will read in one line, and then print it back to the screen. Okay, so let's see what we get when we do that. So now we have the output, and if I bring that over so we can see it, then you'll see the output now. We have one line from the file. Also note that there's a blank line here between the output of the bases and the length, which is 61. So when I printed this out, when I printed DNA line, then I printed out the line and the \n that is included as well. So when we do a read line, we actually read in the end of line character that's still out here. So the print statement, that causes one carriage return, and because we've got a \n, that's another carriage return, so that's why we get this blank line here. Then the next print statement, we print out the length of the line, and that's where we get the line is 61. And if you wanted to count these letters, if you counted all those letters, you'd get 60, and then the \n over here gives us the extra 1 for 61. Now let's add some more stuff to the program. I want to count the number of occurrences of the bases C, T, and G that are in the data line. So we have the DNA line here, and if I want to count how many occurrences there are, I can use the count method to do that. So I have declared a variable, I'm using a variable count underscore CTG, and that equals DNA line, and then the dot, and then the count method will count how many times the CTG occurs in the line DNA line. And then we will print that out shortly. The next thing I want to do is to do a replace. Again, this is similar to the example that we did earlier. And here I just want to do the same kind of replacement, and let's see what kind of output we get. The replacement that I want to do is this one. So I have a variable called new DNA line, and I want to save the result of the replacement in this variable new DNA line. So I'm going to take the original DNA line that we read in up here, and I'm going to use the replace function, and it will search for all occurrences of CTG. And when it finds one, it replaces it with the uppercase CTG. So this will help us to easily pick out where it found a CTG and where it replaced it with this uppercase. So that'll be easy to see. Then let's print that information out to the screen. Now let's print out how many times the CTG appeared. So I've just got a print command, and I'll type this in so we don't have to go through the struggle of watching me type it. So we just have CTG appeared, and then I'm going to convert this count, which is an integer, to a string, and then concatenate it, and then we'll concatenate this afterwards to complete the sentence. Then I'm going to print out the new line that we just made. So I will put that in here, and this will print out our new DNA line that has the replacement that we did here. So now let's run the program and see what we get. First of all, there's a typo, so that's not STG, that should be a CTG. Now it will work, so let's try it one more time. Here's the output. So it said that CTG appeared 2 times in the line. So if you look through that carefully, then you can see where they are. But since we have done the replacement, we have made the CTG, replaced it with TAG, then we can easily see that here is where they appeared. All right, so now we have modified just the one line, and then we have printed it back out to the screen. Let's remove this for the time being. The other thing I want to do now is I want to write that same information out to the new file. So now our out file, remember, is called copydna.txt. So we've already opened that up. So if we want to print the data out to that, then we use the write statement for that. So this line of code will do that. We have our file pointer, out file, write is the method, and the information we want to write is stored in our new DNA line that we created here. So this will just write the one line to the output file. One thing that's very subtle that's going on here, and I will show you this shortly, is this new DNA line, it still has the \n at the end of the line. So when I write this out with write, I don't really have to add another \n because there's already one included in the new DNA line variable itself. All right, well, let's run the program and look at the outputs. The output that goes to the screen doesn't change. So I'm writing the data to the file, so nothing is new here. So let's move this out of the way. And here is our file browser. So we have our copydna.txt file. Let's open it up. And when it does open, you'll see we have the one line. So now the output file doesn't contain the entire file that we had in an earlier example. It just contains the one line. So by using readline, you can process data from a file one line at a time. Also notice that here's the line with our substitutions TAG already in there. Let's process one more line. Let's get a new line from the input file, and let's make the modifications, and let's write that to the output file. So then our output file will have 2 lines of output. Then to do this, we need to do the same thing we just did. So let's use readline to read in another line. So I'll just copy that line and paste it down here. So I'm going to change this. let's say, read the next line. Okay, so this will be line number 2. We'll read that in from the file, and we'll process it the same way. So I can copy all the stuff that we did here. In fact, I can copy all the way up to where we did print that out. So we'll copy all that and paste it here. So we will read in the DNA line. We will print it to the screen. Then we'll get the length, and it's going to be the same length as before. Then we'll count the number of occurrences of CTG in this second line, and then we'll print that out. We'll also replace the occurrences of lowercase ctg with uppercase THE, and then we'll print all that stuff out. So all that will happen again. And we might as well finish this up. When we print it out to the screen, we also want to print it out to the file. So I can also copy this out file.write, paste it down here, and that will process the second line. So what I've essentially done is to just copy everything that we just did and place it down here all the way up to there. Okay, so I did a copy and paste, and now we're doing this twice. So let's try that again. Here's the one line. We have the read line, and then we have the out file.write here. Then from here down, we do the same thing with line number 2. So now let's run the program, and let's see how this changes our file. Now we have the output. Let's drag it over. So here is the second line. The second line shows up there. The length of the line is the same as the first line. That's not a surprise. CTG only appeared one time in the second line, but we did replace it with uppercase TAG. Then we wrote it to the file. So let's look at our output file again. We'll bring up the file browser, double-click on the name of the file. And here our file now contains 2 lines, as you can see. So in line number 2, we replaced those 3 bases. Our file now contains 2 lines. So you can continue to add as many lines as you want to this existing file, stopping whenever you want. So this illustrates what I wanted to do. So we can just stop it at this point. We won't write any more lines to the file, but I want to clean things up just a little bit. Notice that we do get 2 separate lines when I do this. 2 completely separate lines. And if you look at the code, we didn't really do anything special to make that happen. Normally, when you use a write statement, you would have to add on a \n because it does not automatically go to a new line. In this case, though, our new DNA line has a \n already included. One thing I'd like to do is let's see if we can remove that \n and see what happens then. To remove the \n, we can use this rstrip thing, right? Remember that? So when we when we read in our first line, let's go back to our first line up here. Okay, we're going to do a read line. So DNA line is in file.readline. So when we read that in, we get the \n. It's stored in the DNA line. Now, if we want to take away that extra character at the end, then we can do it by using the rstrip. So the way we did that was DNA underscore, whatever your variable is going to be equal to our DNA line. And then I need to underscore there, DNA underscore line dot rstrip. And then in parentheses, we want to put our terminating character. That's what character we're trying to strip from the end. So that's double quote, \n, double quote, close parentheses. That needs to be a double quote, close parens. So this will remove that line feed at the end of our first line of input. Remove, I'll call it the end of line. That's the same thing as our \n. So this strips that off. Now, when I print this out, we're going to find out that it looks the same, but the length is going to be 1 shorter. Instead of 61, it'll be 60. Then I'm going to let the program continue. We'll do all the stuff that we just did. We'll read in the next line and do all the work there, and then we'll print that out. But what does that mean for our file? Well, let's take a look. Now we have the output, and sure enough, if we look at the output, we find that the length of the line is 60. So when I read this in, here's what it looked like. That's the first line. But notice also that when I did the print to the screen, the first time I printed it out and there was a blank line. That's because of that extra \n that we read in from the file and we count it as 61. In this new example, the line length is 60. There's no blank line between the end of this line here and the beginning of this line here. And then the other stuff is the same. Okay, we find CTG twice, we change it, we write it to the file. Then we read in the second line. I didn't strip off that extra \n, so that's why we see the blank here. And then it processes that line and we write it to a file. Now let's go take a look at the file. So I'll move this. I'll bring in the file browser. We'll open up our copy DNA file. And now notice that everything's on the same line. Okay, we have one really big long line. Okay, so the reason for that is that somewhere up here we had a \n in the previous example when we wrote out the line back to the file. When we stripped off the \n and write it to the file, there's no end of line here to make the carriage return for this to go back to a second line like that. So this is just a very subtle thing, but you need to be aware of how these \n's work. Now, we can overcome this by doing one of two things. The first one would be we could just not strip off the line. Not strip off the \n, the end of line. So if we leave that alone, then we're probably okay. Why go to the extra work? But if we do strip this off for whatever purpose, and we want to write the line to the file, when we write it, then this first line, we need to add the \n. Have to put it back in there. So I will need to concatenate a double quote \n double quote, which is pretty common when you're doing a write because it does not automatically have a \n like the print does. So I took it away up here when I did the rstrip, working on the first line. Then when I write that first line out to the file, I'm adding it back in here. So you can do it that way, or as I just said, just don't strip it off to begin with unless you really have to. So now let's take a look at how this affects the file. The output to the screen looks the same, so I'm not going to show you that. But let's bring in the file browser and let's open up our file this time. And now you see we have two lines again. So the reason we have the two lines is because I added back in the \n here when I wrote the first line out. So the first line is written out to the file. Then I wrote the \n here after this AAC. And then when I write the second line to the file, it shows up down here. Now the last thing we could do with this is if we wanted to make sure everything was in lowercase when we write it out to the file, then we could add that in. And that's probably a good thing to do because you don't want a mixed case in your output file like this. So let's make that small change. So we just need to add the lower .lower to the end of the line with this this thing here we called a method. Don't forget the parentheses. So this converts everything that's in our new DNA line to lowercase. So we need to do that here. And we also need to do it for the second line that we're writing out. So I'll paste it down here too. So now when we write the output to the file, everything will be in lowercase. So one final time, let's see what kind of output we get when we have our program modified like this. And also remember that when you're all finished, you should close the files as I've done down here. Okay, let me bring the file browser back over and let's look at our latest version of the file. We open that up and now you see that everything's in lowercase. So this example has shown you how to read data from a file one line at a time, how to process it, and how to write it back out to a new file. So here's another example where you can use multiple files in a program and do some processing on the data as you read the data in and write the data back out again. I think that's good for now, so we'll stop the video at this point.